Hello students. Today we're going to talk about square roots. If you'll remember when you learned perfect squares, a perfect square is the product of a number times itself. So these are some perfect squares. We have 1, which is 1 times 1 or 1 squared, 4, which is 2 times 2 or 2 squared, 9, which is 3 times 3 or 3 squared, and then 16, which is 4 squared or 4 times 4. Of course, we could go on. 5 squared would be 25, 6 squared would be 36, 7 squared would be 49, and so on. And those answers, those products, are perfect squares. And we know they're perfect squares because we can arrange items into a square by having sides that are equal. So if you look at my drawing of 9, we have 3 squares by 3 squares. It takes 9 squares to make one large square with an area of 9. Today when we talk about square roots, we're looking at something that's basically the opposite of a perfect square. So, and I do want you to write this down in your notebook. You can pause this to write down this definition. A square root is the number that was multiplied by itself to get that product. So it's the opposite of a perfect square. So at this point, if you look at the perfect squares that I drew, for example, go back to our 9 as a perfect square, the square root of 9 would be 3, because 3 is the number that I squared to get 9. And I'm going to draw it for you so you can see the way it looks. Okay. The symbol for square root looks like this, kind of like a division sign, but it has that little check on the one side. So the square root of 9 is 3. And we don't write the answer on top like we do in division. We're going to write it with an equal sign and then the number. So the square root of 9 is 3. The square root of 25 would be 5. So please write down those examples. And any number that is a perfect square, you are going to get a whole number as the answer of your square root. So if your number that you're finding the square root for is a perfect square, your answer will be a whole number. So how do we figure out the square root of a number if it is not a perfect square? The answer to that is it's going to be a complicated decimal. It's going to be an irrational number. And so we're not going to actually calculate the exact square root. You could actually use a calculator for this, but you can estimate the square root. And so if you notice, we're going to look at first the square root of 50. We're going to look at some examples that we know. We know that the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. We could keep going with all the perfect squares that we can think of and find the square root as a whole number. But now we're going to use those that we know and estimate when we're trying to find a number that's not a perfect square. So in this case, 50. We're looking for the square root of 50. So we're going to look for those perfect squares that are just below it and just above it, the closest perfect squares to 50. And we know that 50 is going to be between 49 and 64, which means that the square root of 50 is going to be somewhere between 7 and 8 because we're finding the square root of 50. So we're going to write that this is between 7 and 8. And it's going to be closer to 7 than 8. So it's going to be 7.0 something, or it's going to be closer to 7 than it is to 8 because 50 is closer to 49 than it is to 64. So I'm going to underline the 7 because it's closer to that 7. Okay, so we're going to write that example down. And then we'll try one more. The square root of 11. So we're going to look back at our perfect squares. 11 is going to fall between 9 and 16, those perfect squares. So we know that the square root of 11 is going to be between 3 and 4. And it should be closer to 3 because 11 is closer to 9. Okay, so I have our answer updated over here.